Welcome, I'm Jonathan Vennard, Associate Professor of Precision Machining at Vincennes University. In this video, we will establish the X and Z geometry offsets for our lathe tools. The calibrated X0 position is the center line of the spindle, and this is calibrated to the center of all of our turrets' drill holders. We have to tell our turning tools where their tool tips are in reference to that X0 center line. First, we're going to go to the tool setup page, then geometry offsets, and we're going to establish the X offset for tool 1. We have to manually machine the diameter of our part. So we turn on the spindle and hand jog down an X until we see the tool touch our workpiece. We'll move in the positive Z direction clear of the workpiece diameter, and then we'll come in 2 more clicks, which is 20,000ths of an inch in X. Now we can manually clean up the diameter of our part. We'll clean up the surface approximately a ½ inch back, leaving the tool in contact with the part as we shut off the spindle. Now we hit the store position for that tool. It's going to ask for a measured part diameter. We will measure this diameter with our calipers. The machine is going to use this value to calculate the diametrical circle difference from the X-axis center line. It's going to use that to tell us how far our current tool is from this center line position. This could be a positive or a negative difference based on the X position of the current tool. By storing this value, now the machine knows how to travel along the X-axis diameters of our workpiece. Now, if we want to set up another tool, we don't have to cut the part again. We can simply index to our second tool, tool 2, and set it using a pocket scale. I'll get the tip of the tool as close as possible without hitting the part. Now, we will start moving back away in X until our scale will slide through. As we get close, we should always go to a smaller increment. Once the scale slides through easily, we will press store position again. But since we've used the scale on top of the original diameter, we have to add that to that diameter. So our scale was 20 thousandths thick, so we're going to add 40 thousandths to the overall diameter. The diameter with the 40 thousandths added to it will be used to set the X geometry offset for the remaining turning tools. This tool sticks out just a little bit further than the previous tool, so the circle here is a larger number than our 0 calibration circle in X. Now that we have set the X geometry offset for our tools, we can now set the Z offset for our additional tools. We are using tool 1 as the Z calibration tool and to set the work offset in our part setup page. We see this number on the left side of our geometry page. Now we have to tell it how tool 2 correlates with the other tool. With tool 2 in the active position, and while still in the tool geometry offset page, we go to the tool 2 Z offset. Now I'll hand jog out past the face of the part and come down an X to where I'm just off the face, which was our datum surface. I'll move along this Z datum surface and get as close to the part as possible without making contact. Once again, using my scale, I'll start to move away from the face until the scale will slide through easily. Once the scale slides through, once again, we will press store position. The machine is going to ask for a Z position adjustment. I use the scale, which we already know is 20 thousandths thick. So I'll type that in and I'll hit enter. So for this second tool, the turret is 30 thousandths further to the left in the negative Z direction than our Z calibration tool work offset was for tool 1. So now tool 1 is our 0 calibration tool, and our Z offsets for all the other tools are going to be based off the difference of the turret position from tool number 1's position. That allows us to load different length materials into our machine, and all we have to do is face it with tool number 1, and then store the new Z work offset position. And all of the other tools will reference this change and adjust accordingly. That's how we set the X and Z geometry offsets on the CNC lathe. To learn more, look for our other videos on CNC mill and lathe techniques.